Selection within assembly spaces. The concept of the assembly space allows us to understand how selection and historical contingency impose constraints on what might be made in the future. By aiming to detect selection, we mean a process similar to selection in Darwinian evolution. We do not, however, model functional differences that selection might act on. Instead, we account for only the specificity of selection, that some objects are more likely to be used to make new things, and some are less likely. The only functionality we want to detect or describe is in the memory of the process to generate the object, with examples including a metabolic reaction network or genome. This allows three Lewontin conditions for evolution to hold. A key feature of assembly spaces is that they are combinatorial, with objects combined at every step. Combinatorial spaces do not play a predominant role in current physics because their objects are modelled as point particles and not as combinatorial objects, with limited exceptions. However, combinatorial objects are important in chemistry, biology, and technology, in which most objects of interest, if not all, are hierarchical modular structures. More objects exist in assembly space than can be built in finite time with finite resources, because the space of possibilities grows super exponentially with the assembly index. To tame this explosive growth in assembly theory, historical contingency is intrinsic with the space built compositionally, where items are combined recursively, accounting for hierarchical modularity, and this substantially constrains the number of possible objects. It is the combination of this compositionality with combinatorics that allows us to describe selection. Figure 3. Does it describe or quantify, or even just identify? To produce an assembly space, an observed object is broken down recursively to generate a set of elementary building units. These units can then be used to recursively construct the assembly pathways of the original objects to build what we call assembly observed assembly observed A0. A0 captures all histories for the construction of the observed objects from elementary building blocks consistent with what physical operations are possible. Because objects in assembly theory are compositional, they contain information about the larger space of possible objects from which they were selected. To see how we first build an assembly space from the same building blocks in assembly observed, which includes all possible pathways for assembling any object composed of the same set of elementary building blocks as our target object. The space so constructed is the assembly universe.